And the girl in the corner with the scarlet letter, while you're watching, you may think that she doesn't matter, but no one knows you better.
Hi guys, I'm Jubel Laria and I'm here to answer all the activities in Chapter 5. Chapter 5, Ethernet. The OSI physical layer provides the means to transport the bits that make up the data link layer frame across the network media. Ethernet is now the predominant LAN technology in the world. Ethernet operates in the data link layer and the physical layer. The Ethernet Protocol standard defines many aspects of network communication, including frame format, frame size, timing, and encoding. When messages are sent between hosts on an Ethernet network, the host format the messages into the frame layout that is specified by the standards. Because Ethernet is compromise of standards at these lower layers, it may best be understood in reference to the OSI model. The OSI model separates the data link layer functionalities of addressing, framing, and accessing the media from the physical layer standards of the media. Ethernet standards define both the Layer 2 protocols and Layer 1 technologies. Although Ethernet specifications support different media bandwidths and other Layer 1 and Layer 2 variations, the basic frame format and addresses scheme is the same for all the varieties of Ethernet. This chapter examines the characteristic and operation of the Ethernet as it has evolved from a shared media contention-based data communications technologies to today's high bandwidth full duplex technology. So let's start the activity in chapter 5. The first activity is the activity MAC and LCC sublayers. Instructions. Description of the MAC and LLC sublayers are provided in the table. Click in the MAC or LCC fields to match the descriptions to the correct sublayer. Hacker characteristic. So you can choose between MAC and LCC. First is controls the network interface card through software drivers. The answer is LCC. Works with the upper layers to add application information for delivery of data to higher level protocols. The answer is the LC. Works with hardware to support bandwidth requirements and checks errors in the bits sent and received. The answer is the MAC. Controls access to the media through signaling and physical media standards requirements. The answer is the MAC. Supports Ethernet technology by using CSMA or CD or CSMA-CA. The answer is MAC. and remains relatively independent of physical equipment? The answer is the LLC. So let's check. You have successfully matched the description to the correct sublayer. Next activity is the activity identify Ethernet frame and fields. Drag the 802.3 Ethernet frame field name to its description. The field and the description uses pad to increase this frame to field to at least 64 bytes. The answer is the 802.2 header and data. Describes which higher layer protocol has been used. Uh, the answer is the type. The frames originating NIC or interface MAC address. The answer is the source address. Assists a host in determining if the frame received is addresses to it. The answer is the destination address. Notifies destination to get ready for a new frame. The answer is the preamble. Synchronize sending and receiving device per frame delivery. The answer is the start of frame delimiter. Detects errors in an Ethernet frame. The answer is the frame check sequence. Let's check and see the result. You have successfully matched the Ethernet frame field names to their descriptions. And the next activity is activity identify Ethernet frame field name. Instructions. The next activity is activity identify Ethernet frame field name. Instructions. Drag the Ethernet frame field name to its correct location on the diagram. The, the IEE 802.3 Ethernet frame fields. The 7 byte is the preamble and the 1 byte is the start of frame delimiter. The 6 byte is the I think destination address and the 6 bytes again is the source addresses and the 2 bytes is the length. The 46 to 1500 bytes is the 802.2 header and data, and the 4 bytes is the frame check sequence. So let's check if the location of the Ethernet field name are correct. So you have successfully matched the Ethernet frame fields to their correct locations. The next activity is the activity frame forwarding methods. Instructions. Description of switch frame forwarding methods are provided in the table. Click in the store and forward or cut through fields to match the methods to the descriptions, and the store and forward and cut through. So you choose between store and forward and cut through to the correct descriptions. The first is the buffer frames until full frame has been received by the switch. I think the answer is store and forward. Checks the frames for errors before releasing it out of its switch ports. If the full frame was not received, the switch discard it. I think the answer again is the store and forward. No error checking on frames is performed by the switch before releasing the frame out of its ports. I think the answer is the cut through, and a great method to use to conserve bandwidth on your network. I think is the store and forward, and the destination network interface card (NIC) discards any incomplete frames using this frame forwarding method. I think the answer is the cut through, and last, the faster switching method, but may produce more errors in the data integrity. Therefore, more bandwidth may be consumed. I think the answer again is the cut through. So let's check if we choose the right description about the store and forward cut through. You have successfully matched the description to the correct frame forwarding technique. So next activity is the activity frame forwarding methods. Instruction: read the scenario based on the topology shown. Identify how the frames will be proceed by the dragging your answers to the appropriate fields provided in the table. All answers will not be used. This is the port 1, and this is the port 2, and this is the port 3. Switch 1 is a brand new switch. PC1 is sending data to PC2. The PC1 is sending data to the PC2 right there. S1 is using full duplex. The S1 is using full duplex, MDIX, and fast forward as a frame switching method. Cabling used in this topology will be, I think, straight through. To find where PC2 is located, PC1 will send out I think the answer is broadcast data frame. PC2 will respond back to PC1 by sending back a unicast message. If PC2 receives only half of the data in the frame, it will be, I think, discard it because it received only half data. If PC2 receives many damaged frames on port 3, S1 likely will change back to, I think, store and forward. So let's check if the frames dragging will be responded to the appropriate fields provided. So you have successfully matched the network access frame scenario process to the description. So let's go to the summary of chapter 5. The summary of chapter 5: Ethernet. Ethernet is the most widely used LAN technology today. It is a frame of networking technologies that are defined In the IEEE 802.2 and 803.3 standard, Ethernet standards define bulk and layer 2 protocols and layer 1 technologies. At the data link layer, the frame structure is nearly identical for all bandwidths of Ethernet. The Ethernet is the frame structure adds headers and trailers around layer 3 PDU to encapsulate the message being sent. Um, One most Ethernet networks and devices are typically connected on a point-to-point basis to a layer 2 full duplex switch. A layer 2 LAN switch performs switching and filtering based on the OSI data link layer. The ARP relies on certain type of Ethernet, the broadcast message and the Ethernet unicast message. That's what we call ARP requests and ARP replies. The ARP protocol resolves IPv4 addresses to MAC addresses and maintains a table of mappings. So that's all the activities in chapter 5. The activity identify Ethernet frame and field names. The the activity identify Ethernet frame field names part 2. The activity frame forwarding methods. The activity frame forwarding methods.